This video is to describe how to put together your lab notebook for the University of Indianapolis organic chemistry classes, starting with CHEM251. So what we're going to use is, instead of using the more expensive carbon copy notebooks, we're going to use 2 composition books. And those composition books should be arranged, let's see if I can do this, so that this edge is sewn or bound. Right? You want composition books with a sewn bound edge, and you want no perforations. The pages have to be permanent. We never tear a page out of our lab notebook. And we want 2 so that in 1 week you work in book 1. The next week you turn in book 1 for grading, and you work in book 2. After book 1 is graded, the students will return it to you in time to get ready for the next week. So then in the 3rd week, you turn in book 2, work in book 1. And you keep alternating through the semester so that the student lab assistants have 1 book to be graded. You have a book in your presence to get ready for the next week's work. And so we'll alternate books through the semester like that. So you need 2 copies of these. We use these because they're cheap. They're a few dollars in the bookstore. You can get them for as little as $1 in a discount store like Target or Walmart. So you just need to get a couple of bound composition books. In each book, take a couple of pages and leave them blank for a table of contents. So each book should have a couple of pages at the start free for a table of contents, right? Each week you work, you'll put the title of the laboratory and what page number that starts on. When you finish a lab write-up, you'll fill in the final page number for that work. Now, since we work in order, there might be 1 week where you start a lab, have to do some work in another lab, and then come back and finish a lab, and so those might be broken up. You don't leave any pages. You fill the pages of your lab notebook sequentially. You just note in the table of contents, here where the pages are. So it might be, this would start like 1 through 6, then you go do something else, then you get to work on the lab again, and maybe it starts, and goes from 9 to 11. And you just put the pages where that information can be found. But you never leave space in your lab notebook. And then as you do work each week, you need to come in and fill out the title for the next thing. So the title of your second lab and your page numbers. So each week, the lab assistants will check to make sure your table of contents is up to date. So the first few pages, 2 or 3 pages of each lab notebook, you want to leave for a table of contents. Okay, so remember, 2 copies of the lab notebook, right, as a bound composition book with a stitched binding, right, a stitched binding along that side, and no perforations, so we don't have to worry about taking any pages out. Okay, so after your few pages at the start for a table of contents, you're ready to start your lab notebook. So the next thing you will do is you will write down page numbers, just start in your book and fill in page numbers only on the right-hand page. Note I'm not showing the left-hand page. The left-hand page will always stay blank and can be used for scratch paper. What's on the left will not be graded. right? So whatever you write on the left-hand side of the page, we're not going to look at. We're only going to look at what's on the right. So only number the right-hand pages. So start with 1, turn the page, 2, turn the page, 3 on the right, turn the page, 4 on the right. Everything's on the right. Now, this is an example lab. This is not the lab we're going to start off the semester with. So don't just copy this lab. We've had students do that before. This is an example of a comprehensive lab or a comprehensive pre-lab. So you're going to start out, and each lab will have a title, right? And you have to put that title here and in the table of contents. And then each lab will also have a purpose, right? So part of your pre-lab is writing the purpose. We want you to be aware from the beginning what you're trying to do. So the purpose has 2 parts, right? Part 1 is, what do you want to accomplish directly in lab? Right? What are you actually going to physically do in the lab? The second part of the purpose is why, right? Describe what you are supposed to learn. By doing that exercise. So when you see here, there are the 2 parts. So the first part, if I go on here, the purpose of this exercise is to separate the acidic substances 2-naphthol and benzoic acid from a mixture of these with 1,4-dimethoxybenzene, right? That's what we want to accomplish in the laboratory, right? Now, what are we supposed to learn? This laboratory will introduce the use and handling of the separatory funnel, so we'll use a new technique. We'll learn about the extraction and recovery of substances from a mixture. That's something important. And we'll use something about differences in the strengths of acids in the mixture to separate them. So there's some acid-base chemistry, right? So that's what we're supposed to learn about. So there's the thing we're supposed to accomplish and the thing we're supposed to learn. Okay, so each lab should have a purpose that addresses both of those topics. Now, whatever chemicals we're working with in the organic chemistry laboratory, we assume they might be toxic, and we need to know their properties. We need to know something about their safety, and we need to know something about their physical properties. In this case, because we're trying to separate things, we want to know what they might be like when they're separated. So, each lab then will need a table of reagents, and in that table of reagents, you're going to put the name of the compound, its formula, its structure if it's known, and then important things that you need. Its molecular weight. In this case, once we separated them, we might do a melting point, so we know their melting point. We said something about acid-base chemistry. We need to do their pKa. If you know the amount, you should calculate it ahead of time. In this lab, because we're working with an unknown, we don't know the amount, and so we have to address that. And then we're also going to deal with safety information, right? Anything related to working with this material safely, you have to put in the table of reagents. Right? So here our table of reagents is going to continue. And so here are the safety warnings for working with benzoic acid. And you see our table of reagents can continue, right? Here's another thing, in this case, another thing that might be in our mixture. We don't know what's going to be in there. Again, we don't know how much, right? There's an estimate from the lab. We've got its structure, we've got its formula, we've got its molecular weight, we've got its melting point, we've got its pKa, we have its safety warnings. So everything that we're going to work with, we need to look up that information, right? And in terms of the physical properties, right, when we're talking about these physical properties, you have to be aware of what you're going to do. In this case, we're isolating solids, right? Their melting points are above 25 degrees Celsius, which is room temperature. But if they had low melting points, or if they were liquids and we were going to boil them, then a boiling point might be more appropriate than the melting point. You need to think about what you're going to do and what physical properties are appropriate to list based on what you're going to do with that material. Okay, and you see now that we continue this with, right, the third thing would be 1,4-dimethoxybenzene, its safety information, its physical properties, right, its amount. And in amount, if you're doing something where you're doing chemistry and stoichiometry is important, you need to put amount, let's do this with the pencil, right, you need to put amount in both grams and moles, right? Remember, when we're doing stoichiometry, the number of moles is how things are related in chemical reactions. So you need the number of grams, because that's what you're going to go to the balance and weigh. You need the number of moles, because that's the unit in which you'll balance the chemical equation if you need to do that. Right? You see my table of reagents is continuing. Not only am I doing the components of the mixture, you see here, this tertiary butyl methyl ether was the solvent that this lab was performed in. Right? In tertiary butyl methyl ether, we had a lot more safety warnings because this was this thing that was extremely flammable. Vapor may cause a flash fire. Warnings about how to handle it, right? All described in the safety information. Okay? We're also using water, right? So there's water. So the table of reagents, depending on what you're doing, can be quite extensive. And again, you have to be aware of what physical properties you need. In this case, we're going to be doing a separation of the ether and the water. So knowing the density is important. We need, right, here's the density of water. There's the density of the ether. So when we've got them in the same place, we know the ether is less dense, and it would form the lower layer between these two immiscible liquids that won't mix. So in this case, because we're going to mix them, density was important. And you can see here another point. I had made an error. Right? I had made an error. I didn't note, but at the start of every work period, you put the date at the top of your page or wherever you start on that page. In this case, I had gone back. I had started this before August 25th. Right? I had started this before August 25th. As I was working with water, I put the density, and I realized I need the density of tertiary butyl methyl ether, and I hadn't put it there. So I went back and added it, and I made a note that I modified that on a specific date. I put my initials and I put the date to say that I added that modification on a date different than the date originally put at the top of the previous page. So continuing the table of reagents, we need some sodium hydroxide. Again, safety information on sodium hydroxide. Sodium bicarbonate. Again, safety warnings. We're going to use some salt in this. Physical properties and safety warnings of the salt. Right? So the table of reagents here is continuing, depending on how many reagents are needed for the particular lab exercise you're doing. My table of reagents continues. Again, calcium chloride, safety information, right? Calcium chloride, safety information. So when you're done with that, if there is a chemical reaction going on, now remember, early in the semester, we're going to be doing some separations based on physical properties. The identity of molecules is not changing. If they're in a mixture and then we separate them, we have the same kinds of molecules we had at the beginning. So at the beginning of the semester, there will not be chemical reactions occurring. That is, molecules changing identity as a result of what we do with them. They may change their position, they may change their state, but they're not going to change their identity. So early in the semester, you may not have a chemical reaction section. But when you are performing reactions, you put the chemical reaction section and you write out the balanced chemical reaction for each reaction that will occur. And in organic chemistry, it is perfectly appropriate to mix structures and formulas in that balanced chemical reaction as long as it's balanced properly. Okay? And it's important to know what your balanced chemical reaction is. So for instance, in this laboratory, note that one of the products is the gas carbon dioxide. I was actually in a lab one time where someone forgot that when you mix an acid with sodium bicarbonate, which is baking soda, you get carbon dioxide. He tried to put it in a container that he was holding closed tightly. When the carbon dioxide gas was released, it pushed the lid off the container and poured dangerous chemicals on the floor and caused a spill because he forgot what the chemical reaction that he was doing was going to be. So you need to be aware of your chemical reactions because it can have safety implications as well as educational implications. So in this case, we're doing acid-base chemistry, right? So we're showing an acid-base reaction of a weak acid with sodium bicarbonate as the base. And here the chemical reactions are going to continue. And so I was going through the chemical reactions and note, here we go. Ooh, I apparently forgot something in my table of reagents. I forgot that we needed hydrochloric acid. So what did I do? I just went back. I didn't panic. I just added a correction at the point where I found it. And then did all the things I need, right? I had the molecular weight, but I noted it was aqueous, and so I talked about aqueous hydrochloric acid has that kind of concentration, and here is the safety information. I also needed some litmus paper, so I just made an addition to my table of reagents at the point when I realized I'd made an error and left something out. That's perfectly appropriate. You don't get counted off as long as everything is complete by the time you show up in lab. Okay, so I go back to the chemical reactions, right? Again, showing chemical reactions, right? I needed hydrochloric acid so that I could react my base with the hydrochloric acid to recreate my benzoic acid, right? So here's, again, a base with an acid to recreate the acid. Here is the complexing of calcium chloride. Calcium chloride binds with water to incorporate water in the crystal as a way of drying, and we'll talk about that later. Okay, so again, you just lay out your chemical reactions, right? One at a time, very clearly, showing them in a balanced form. Now, if you're doing something new in a new technique, and we'll be doing this a lot, especially during the first semester, there may be some new equipment that we haven't used before. And so part of what you need to do to be prepared to work productively when you get to the lab is you need to know how that new equipment should be set up and what it should look like. So in this case, we're going to be using the separatory funnel on a ring stand. So you should be able to draw that new equipment so that it helps you be ready to set it up in the limited time we have in lab. So we're going to be doing using a separatory funnel. We're going to be using, in this case, we're going to be using a vacuum filtration apparatus. Again, you should show how that is going to be set up and what it should look like, right? How that's supposed to go together. Again, so that you can be prepared to set up and work efficiently once you get in the laboratory. Now, once you've used a set of equipment once, when you use that again, you can refer back to a page, right? Based on the page number, you can refer back to the page in your lab notebook where you've used that before, and you don't have to draw it if it's something you've used before. You only have to put in this equipment if it's something you haven't used before. Okay, now, if you're doing a chemical reaction, here you would calculate the theoretical yield. This is where your general chemistry gets tested. So you have to know what the limiting reactant is, and you have to go through and do a limiting reactant, a product calculation based on the limiting reactant that determines your theoretical yield. Now in this case, we're doing a separation, and your yield is based on the unknown mixture that the lab assistants put together. So here we don't have a theoretical yield. But if you're doing a synthetic reaction where we're starting with some amount of starting material and we're going to make some amount of product, we want to know how much we expect so that we can compare what we got to what we expect to see how efficiently our reaction proceeded and how well we performed our techniques. Do not be surprised. A lot of organic reactions have relatively low yields, from 40 to 70%. Often we don't expect near 100% yield. So you don't have to worry that you've done something wrong if you get a yield less than 100%. That's expected in organic chemistry laboratory. But you want to work efficiently and neatly to maximize your yield as much as possible. Now, we want you to come into lab ready to work effectively. So one of the things we want you to do is we want you to be able to make a procedure flow chart, right? And so this is something that programmers used to use. Somehow they don't use it as much. So when programmers use this, there is a code, right? So a box is a step, right, in the process. So every step should have a box. And it's only what you have to do. This is your working document. So when your hands are full, you can glance down and there's good space in between here so that you can see this is what I'm going to do first, this is what I'm going to do second, so that you can glance at this as it is laying on the benchtop and know what you're going to do next without having to read through the paragraph in your lab text, right? That you can't read while you're busy, okay? And so you'll do that. So every box is a step that you're going to perform, okay? And as you're doing this, right, you can tell yourself, make little notes about the technique. So you're going to put together a flow chart of your procedure. Now you'll see this flow chart is extensive and will go over a couple of pages. So you see it's continued on to the next page. Okay? So here's our flow chart continuing, right? And you see more steps, right? And in flow charting, if there is a separation, right, a dividing, in computer programming, it's a decision, right? So in this case, we're separating. One thing is being put in flask 1, the other thing is going down another path. So you can use diamonds for breaks or decisions, right? So that's what diamonds are, is breaks in path where the path splits, or places where you have to make a decision about what you're going to do with something. So again, you continue the flow chart, right? And here our flow chart continues more. Now note, right? Here I started to make a diamond and I made an error. We don't white anything out. Any errors stay. You just make, right, a nice little correction mark. Nope, that's not the right thing. And you fix it, right? Any errors we make become part of the record. We don't hide the errors that we make. The line through them should let you still read whatever was originally there so that we can go back and trace our errors if we need to. Again, making an error and correcting it this way is really doing it properly. If you try to do something else, then you're actually doing a lab notebook improperly. So you see here we have more steps, right? Shown by the rectangles. We get to another diamond where we can have, right, multiple choices. There should have been an error there, right? So again, here we have a division of path and decision making and separation of materials at a diamond, right? Here we have more, right? You can follow through, but this was a fairly complicated flow chart. And again, here I tried to save a little space by putting, right, making it clear that this part of the flow chart was separate from this part. So, right, we had one part here, another part there, right? So as we recovered material, we recorded mass, right? Here's something going into flask number 3, right? That's going to continue on the next page. We make it clear what's going to happen. Right? Here, note, here again is another error, which we can still clearly see, but it was clearly corrected, said, hey, don't read that, right? Start flask 3 with this, right? There's flask 3 starting. Flask 1 has been sitting since a couple of pages ago, so we have to deal with flask 1, and so we end up, right? You end with, right, a box that says, I'm done. Okay, now here you see, in this process, I left out a chemical reaction, so I just went back, added it after my flow chart, check, and now you have completed the work that you need to do before you come to lab, right? You need to do all of that work as part of preparation for lab. When you come in, the lab assistants will check, or your lab instructor will check. If you're not prepared, we can send you out and you'll miss lab and you won't get credit for it if you don't come to lab with your material prepared. Now, once you get to lab, right? Once you get to lab, you're going to have, right, a procedure and observations, right? So this is your record of what happens in lab. So at every step, right, at every step that you do, you need to write something down. You need to describe what you did. And as a result, you have to describe then what you saw as a result. So you added 5 milliliters of the acid. When you added that, bubbles formed, right? You need to write that down. These can be written, right? Because you're busy during this time, it is acceptable to write this in sentence fragments. But even writing in fragments, you must create a complete record. Right? Now, one of the complaints about this is students will be working on this and they'll say, well, why do I have to write down what I did if I said I was going to do something in the procedure? Well, there's a thing in lab. It is lab procedures almost never work 100%. In almost every lab, something will go wrong. You'll have to do something different because something unexpected happened. And so your flow chart is what you planned to do. This is describing not just what you did, what you really did. right? Because there will often be differences between what you plan to do and what you really did. And so you have to keep a complete record of what you did and what you saw. Okay? So, this is your work that you do during lab. Right? The procedure and observations is the record of what you did during your time in the laboratory. It should all be written in the laboratory. It should be complete before you leave the laboratory. Now, note, right, here we go, right? Lab was on a different day, so we put a new date at the start of lab that day, and you write your procedure and observations. Okay. Now, when you're done with lab, you've got a set of observations that at the moment are just disconnected sentences, right? And so you need to bring those together to make some trend. And so your next step after lab, the first thing you do after lab, is talk about results and discussion. Right? That is really describing right? What do the observations mean? Right? You got to figure that out. You have to think about the observations. So results and discussion are about creating order or a synthesis of the observations. And so that can be in a variety of forms, right? A synthesis could be a graph or a plot of numerical data. It could be a description of a change observed. Right? So you're going back into your procedure and observations and picking out the things that are telling you something happened and noting them in a way that brings them together so that you can use them. Right? You know, was there a trend in numbers that you can graph or plot in a particular way? Right? Did you start out with a white solid and now you have a yellow solid, right? That's a description of something that changed. Did you start out with liquids and now you have a solid? That's a description of a change, right? So whatever it is that is a change, right? That's what you describe in your results and discussion, right? So your results and discussion is really bringing together your data in a way that shows that something happened. Okay? So you do that. Now we have to decide, right, the conclusion. Right? So when you get to the end, I apologize for the change in color here. I assume I probably don't want to use my yellow pen anymore. So when you get to the end, you're going to have a conclusion. Okay? And your conclusion should refer back to your purpose. Right? Your conclusion should refer back to the purpose. And so what you have to really describe is what evidence do I have from the procedure and observations as brought together in the results and discussion that I accomplished the purpose stated at the beginning. Right? So one thing you notice here, right? One thing you notice here is that the purpose, you have to be thoughtful in your purpose, because your purpose is really setting up the conclusion, right? Without a good purpose, you're going to have a weak conclusion. So you have to think up front what you want to accomplish and make sure that that's consistent with what you're really doing, okay? And then remember here, it's about evidence, which means you can't cite anything as a conclusion that you can't refer back to in either your procedure and observations or in the way you brought those together in the results and discussion. Everything in your conclusion has to originate from something you saw or some trend you saw in that you brought together in your results and discussion. And so you'll write that in complete sentences, and you have to deal, remember, with the two parts of the purpose. Right? So what evidence do you have that you accomplished the physical, discrete goal of the lab? Did you make the thing? Did you separate the thing? Right? Did you accomplish that? And what evidence do you have that you actually learned the lesson that the lab was supposed to impart? It takes all of that to write a successful lab report in the organic chemistry class. So when you're done with that, you would bring this back to the next class period. So you turn in one book at the next class period, and you would write your pre-lab for the next exercise in the other copy of your lab notebook. Okay? So I hope this helps you prepare your lab notebook. Some of you have lab immediately at the start of school on Monday afternoon and Monday evening. So you're going to have to prepare your lab notebook based on some of this support. Remember, the lab that's shown in the example on ACE and that I've used for this example is not the lab we're going to do on Monday. We're going to do a recrystallization lab on Monday. You should read that, and you should use those procedures to write your own pre-lab for that to be prepared for Monday. I hope this was helpful. If you have any questions, please let me know. Thank you.